So now that we've listed three main aspects of designing a course, let's start with the first one, establish the learning outcomes or learning goals sometimes. So learning outcomes are statements on the state of students' knowledge at the end of the course. Okay, what does it mean? That they state what the student understands, that's the declarative knowledge, and what the student can do, that's the procedural knowledge, skills, at the end of the course. So remember, learning is about knowledge of these two kinds. So learning outcomes are at the end of the course, what is the knowledge that the student has gained as a result of this course? Okay. So there should be statements with the implied starting at the end of the course, a student will be able to, will understand this, will be able to do this, etc. So I put down, for example, at the end of the course, OS course, for example, a student understands how an operating system works. He can write some small scripts to make an operating system calls. Okay, so these are example sample learning outcomes. So typically they are high-level statements. For a course, generally a few, 5, 6, 7, certainly less than 10. For example, in my institute, we require it to be less than 6. You cannot give more than 6 statements. This is not the topics that you cover. These are learning outcomes. What kinds of knowledge does the student have at the end of the course? And of course, the learning outcomes should be achievable in the time that is available to you, that is a semester. And yet it should be ambitious that you ought to push the student within bounds. So for core courses, typically these learning outcomes are established and then revised frequently, as and when. Maybe every time it is taught, the instructor may revise them somewhat. For electives and new courses, they have to be defined from scratch, right? That's how typically. So now, how do you state the learning outcomes? If that's the starting point for entire course design, for designing what you're going to teach, for assessment, everything rests on learning outcomes. How do you state the learning outcomes? How do you put them there, right? First of all. So far we've focused on only two types of knowledge. The student should understand something, should be able to do something. These kinds. So with these, you can state LO in terms of understanding and capability. But this is too restrictive. We need a richer vocabulary to express the learning outcomes for different subjects, because it's engineering, math, sciences, social sciences, humanities, everywhere. Every course has learning outcomes. So Bloom's taxonomy provides the vocabulary to state the student learning outcomes. Okay. So Bloom's taxonomy, as I said, this is probably the most widely cited, used concept or framework in the field of education across all disciplines, I believe. So Benjamin Bloom, he published this taxonomy in 1956 as part of a commission to express what they expect students to learn as a result of instruction. So it was really meant to state learning outcomes. Okay. And it has been translated into 22 different languages, and the most common use of the Bloom's taxonomy is to specify curricular objectives. Not course learning outcomes, but also there can be learning outcomes at the program level, etc. So curricular objectives are there, and also what will you test the student on can be specified. So what's Bloom's taxonomy? We'll do a very brief overview of it, and then I will post on Google Classroom a small paper on Bloom's taxonomy, those of you who want to read it. But there are so much material available online to study. Okay, so he said 6 types of learning are identified. And from lowest to highest, remember, understand, apply, analyze, evaluate, and create. I will go into them, so don't worry if you. So 6 levels of learning, 6 types of learning are there, from simple to more advanced and abstract or more complex. So remembering is the simplest, understanding is a little bit more advanced, more abstract. Apply something that you've understood is yet more complex. Analyze means not only do you understand and apply, you have to analyze things, evaluate, and create is, of course, that you are creating some new thing. So the categories form a hierarchy from simple to or concrete to complex or more abstract. And learning outcomes, therefore, with this can be stated as, at the end of the course, the student will be able to understand something, apply something, evaluate something, create something, for example, if we use this. But even this is not very expressive. So to make it more expressive, for each category, a list of verbs is given, which you can use to state your learning outcome. So let's see what is there. Right? I just picked out some. I'm not giving a comprehensive list. So the first one, the lowest level of learning is, remember, this is retrieving relevant knowledge from long-term memory. So the student remembers something. So you can say at the end of the course, the student can recognize certain theorems or certain concepts, he can recall some facts, some theorems, some figures, right? So these are all around remembering. So you can of course use remember, but you can use also words like at the end of the course, the student will recognize this, recall this, can recollect this, whatever, right? You can use these. Understand. So these are determining the meaning of some instructional message that you may have given in oral, written, etc. Right? So what is you can say the student understands, or you can say the student can interpret a certain equation, can exemplify, classify, can summarize some things into some data given, can summarize into some form, can infer something. These are all under understanding. These all indicate the understanding level of knowledge. Compare, explain, etc. And then the next higher level, more abstract, once you understand things, and for understanding you may need some facts and figures which are under remembering. Now you also need to apply, you may have in a course, you may have some knowledge that is to be applied to some problem solving. Okay, so first two are about knowledge, declarative knowledge, and now we are slowly moving into the procedural knowledge, capability of applying the declarative knowledge for solving problems. Okay, so apply, use a procedure in a given situation to solve some problems, execute it, solve equations using Pythagoras theorem or whatever theorem, etc. Right? Execute it, implement it, various kinds of things around that. Okay. The next higher level is now you're analyzing. You of course you have the ability to apply the concept, but you are now also breaking the material into different parts and analyzing it. How do they differ? How are they similar? What are their attributes, etc. So analysis is somewhat higher level skill where you need to sort of break the material and then do that. Then evaluation is making judgments based on criteria, standards, and doing some some critical analysis. You need to do some analysis to evaluate. But once you analyze, now you can do some judgment based on some criteria to say this is somewhat better, this is 20% better, etc., etc. So you can check, you can critique after you've analyzed. And finally, there is create. You put the elements together to form a novel, coherent whole, an original kind of product. Write a story, write an essay, make a plan for something, etc. Produce something, right? So this is a figure I've just picked up from this Vanderbilt University. So you can see, remember is at the sort of basic level of knowledge. Basic knowledge is just facts and figures. You just remember, mug them up. That's the very basic knowledge. Probably at college level, that I haven't seen a course where remembering is one of the learning outcomes. Right? Those are probably more important for school level. Understanding, of course, is very important in many of our courses. What does the student understand? And on the right, it gives a whole different types of verbs: classify, describe, discuss, explain, all those kinds of things there. So understanding, what do you understand as a result of this course? How do machines work? How does the electric motor work? What's the relationship between voltage and current? How is pressure and temperature and volume related? And what happens if one goes up and all that? All those things are understanding. And then you apply it, you learned all the theorems, all the Newton laws, and the laws of motion. Can you apply them to solve some problem? You understand them, but can you apply them to solve them? Analyze, and of course we want in most of our courses, certainly in engineering courses, these higher levels become very important. Apply, analyze, and its examples are given: differentiate, organize, evaluate, then you assess and produce a new course or original. I'll soon give you a set of examples largely taken from my institute, because in our institute every course has to specify learning outcomes. And when I was the director, I would review every course's learning outcomes, even from every area, every this thing, because I may not understand the topics. All of us can understand learning outcomes, as you'll see. But before that, let's now, just to make sure that you have a good understanding, let's now do some little exercises on this. Right? This is just to make sure that you understand. So we'll do these exercises, but before that, let me give you some little more as to how do you use Bloom's taxonomy for establishing learning outcomes. So learning outcomes, as we know, are statements about the student's knowledge and their claims on the student's knowledge. And as I mentioned, the course can have a few learning outcomes, half a dozen or so. It's not a list of topics. It is about what the student understands and what are the capabilities. And you can use the Bloom's taxonomy. So the list under each category is not exhaustive by any means. You can use many more verbs, many more to express the LOs that you want. We'll come to it as to what is important is that they ought to be about the student's knowledge and they ought to be measurable. Whatever you state, it ought to be measurable. Measurable means that you should be able to assess that learning outcome. How well the student has achieved that learning outcome, you should be able to assess it through some instruments: interview, exam, project, assignments. You should be able to assess it. So I'll give you an example, and these are real. I picked it up. And so let's say intro to programming. Objective 1, I picked it up from some institution, I won't name it. And this is what they had stated. This course provides students with an entry-level foundation in computer programming. The goals of the course are to develop the programming ability in students and to improve their proficiency. Topics include this concept, that concept, this, that. Okay, as you can see, this is very teaching-centric. Course provides this. These are the topics that are included. This is all about teaching. The course will teach you this. It will provide you this. These are the topics that are covered. With learning focus, we need to make statements on the learner's knowledge. Okay, so let's see that. So this I picked up from our own institute. So again, same intro to programming course. So at the end of the course, the student will be fluent in the use of procedural statements, assignments, conditional loops, etc. Student is able to code, test small Python programs that meet the requirements written in English. Understand the concept of classes and objects and write small programs using them. There is about one or two more. But you see, each of these specify the knowledge that student can expect to have at the end of the course, and they can be assessed. Whether the student can use these loops, conditionals, I can give programs and check whether he can do it or not. Be able to code and test these things. Give the student a bunch of problems, ask him to code. If he can, he's met this learning outcome. Similarly for 3. So they state what the student knows at the end, what the student can do, understands, and do at the end, and we know we have ways to assess it. Okay. So now this is an example I've given. I'll give you some more examples. But before that, let's just get a little deeper, a little bit more familiar with Bloom's taxonomy. Okay, so I'll give you a set of quizzes, quick quizzes, to do this. And this is a numeric quiz. I'll give you, started the quiz. I've given you the 6 levels here. On the right side, there are 2 learning outcomes mentioned at the bottom. Please tell what level do they belong to. Type in a number in the ALT. Otherwise, type in a number in the chat box. Okay, let's see in the chat box what is coming out. Okay, so both of them actually are of the same sort of level. At least I tried to do that. There's 2 learning outcomes, not stated them. Right. Okay, so many of you have stated 3 clearly, and let's see. And these are, by the way, these are. You can argue, somewhat differently as well. That's not a problem. So develop algebraic and numerical models using suitable theories. Using suitable theories that they have learned. That's applying those theories to develop this. Use constrained optimization to build the model. Use constrained optimization, producer behavior. Again, how do you apply? How do you use these equations to solve something? So that seems to be, to my mind, fall under application of some concepts that were taught. Okay. Now let's look at another one. So explain the difference. So the learning outcome is, at the end of this course, the student can explain the difference between critical and creative thinking. Many have said 2, which seems to be quite all right. After all, which is saying, explain the difference. Sorry, I should go back. Explain the difference. So do you understand what is critical thinking and what is creative thinking? And if you should be able to. Explain this, right? So if the student has this capability, this can fall under the umbrella of understanding category. Okay. Yes, so correct answer is 2. All right, let's look at another one, which is, okay, so this is another one. Please look at this. Compare the performance of several implementations of the program. Okay, let's see, what are we saying now in this one? Okay, many of them, so there's some 5, some 4. And yes, I can see it can fall both in 4 or 5. I have myself put it in 5. That is now, we are saying at the end of the course, the student can compare performance of several implementations of a program. this is really evaluation of different possibilities. But I can see you can also call it an analyze. You can analyze these things. So it can fall in either of the two categories, I guess, right? And that you will see always. There is not like math that there is a unique answer to this. Okay. Let's now look at yet another one, and then we sort of done. Right. So if many of you are saying 4, it seems quite all right, because this is saying that can experimentally analyze or evaluate the performance. So clearly it is in the measure is in the realm of analyzing something. So this seems all right, and just let's look at the final one, and then we are done. Okay, so many of you are saying 4. This almost seems like to me possibly, unless it's a simple question that is answers are known from before. If they're conducting a new kind of study, then this is likely to fall under 6. They are creating new knowledge through conducting empirical studies, sociological methods. Then they will have to assess it and say something about society. So that seems like creating new knowledge. Now you have good familiarity with Bloom's taxonomy, using it for establishing learning outcomes of a course. So what I've already shown you, for example, learning outcome of a course on Intro to Programming. Let's just look at a few more learning outcomes from different courses, from different disciplines. So you will see that Bloom's applies to everything. It is not tied to engineering or computer science or any such thing. So I picked this up from IIIT Delhi. So for example, the Intro to Microeconomics has this. At the end of the course, the student understands the mathematical models of economic theories. He can develop algebraic, graphical, and numerical models, just what I gave as a exercise. Can use constrained optimization and equilibrium analysis for consumer and producer behavior. So again, applying, this is an application, can analyze the interplay of market, power, and all that. So you can see it has understanding, analysis, and evaluation. It has at least these levels of learning outcomes at these levels. Critical thinking, uncover common prejudices through knowledge of semantic maps and territories. So this is really this could be you can through maps and territories. This is, do you understand? But it can also be applying. Demonstrate the difference between critical and as we've already seen that. Spot common fallacies in arguments. So this will be applying whatever frameworks they learn for fallacy detection to spot them. So this seems like an application. Spot the difference between formal and informal logic. That also seems application level. So there's some understanding, some application level, and these are not complete. I've just picked up 3, 4. Typically, there would be half a dozen, right? So there would be a couple of more. So don't think that these are the full set of learning outcomes for a course. There's likely to be at least maybe two more. Okay, let's look at a math course, probability and stat. Okay, so derive conditional PDF, PMF on a common random variable. Right, this is clearly applying whatever one has learned. Derive sample mean and variance, again applying the formulas that you've learned and the concepts you've learned about that. Derive estimates of parameters, etc. And now this is saying perform math lab experiments to present data, generate data, distributions, etc. So this can form under analysis and evaluation depending on the type of problem. Okay, so math also we've discussed social science, computers. The last two were computer science, social sciences, math, and let's look at computer organization, which is both computer, engineering kind of course. Understand the different components in a computer hardware, the role and how they communicate. So this is understanding, of course, the word says that. Write programs in assembly language. So you learn the assembly language, you apply all those rules, so you can sort of consider it as application. It's not really create, because you're not creating simple things, you're probably just applying the rules, but people can also categorize it as creation. Compare performance of several implementations, we've already discussed that. Analyze processor performance, analyze basic this thing. So this is clearly in the analysis work. So you can see just the ones that I've covered, is none of them has anything on remembering. As I said, in college level, you will rarely have something at level 1, learning outcome at level 1. Mostly it will be level 2, 3, 4, and 5 in most cases. In some advanced courses, it's also going to be level 6. Right? And as I said, a level 2 is up to level 2 is mostly about understanding. 3, 4, 5, 6 get into skills, into applying and skills. Okay, I'll leave these examples for you to read later on. I'll post these PowerPoint slides should you want to. But I've given you example from math, from psychology, from sociology, so you can see that you can actually apply these principles across the board. Right? They're not tied to any discipline. So now we've learned what is learning outcomes. We've learned how to state them. We've learned how to apply Bloom's framework for using them. We've seen a bunch of examples. So now when you have to apply it for your own work, then let's just discuss a little bit on how do you develop the learning outcomes for a course. So first of all, if it's an old course, you'll find statements like "we will teach, students will learn." Please remove them. First of all, first exercise, remove them, and then use Bloom's taxonomy framework for developing the learning outcomes, as we've discussed. Understanding, there is hardly going to be anything in level 1, so what is the level 2? And what skills and capabilities they should have. 3, 4, 5 is what you are likely to see most. In some courses, you might also have 6. Okay? Each learning outcome should be assumed to have a prefix, as I've been saying. At the end of the course, the student will be able to do this. And the actual verb that you use, the term that you use in a learning outcome, can be whatever is appropriate to the discipline and the course that you are saying. It needn't be just the words that Bloom has mentioned, even under analyze and all that. As you've seen, we've given many examples, and you can develop proper verbs for your discipline also. So that's all right. But they should fall in one of the 6 categories. So when you use some new words, just mentally see where are they falling. Is it for understanding? Is it for analysis? Is it for evaluation? Where are they falling? So try to do that, so that ambiguity should be minimized. And finally, the learning outcome should be measurable, in the sense of not measurement of that kind that you should be able to assess and say this student has learned better than the other student. This student has achieved more learning outcomes or learning outcomes better than the other one, right? We have to finally do that. And you ought to be able to, not just to assess, to give a grade to the student, but we ought to be able to say that this learning was really deep and proper, or this learning was very shallow. So for each learning outcome, you ought to be able to assess and also grade, measure whether the learning is better or good or not so good. So these are some of the things that you can do to design learning outcomes. How do you analyze learning objectives, outcomes? Okay, so you should, of course, first see how suitable are the learning outcomes. Are they suitable? Are they too low? Are they too ambitious? If you're putting down just some simple things, at the end of the day, they'll learn, at the end of the course, they will learn the simple equations, how to solve simple equations, learn all these theorems. You've not really, they're too low perhaps. Are they too ambitious? They learn how to design a computer? Of course not. In operating system, they will learn how to design a modern day operating system. They can't do that. It takes years to design and build an operating system, right? So you have to have those that you can do in a semester. Are they achievable with the expected effort? Because after all, in a course, a student is expected to spend only 8 to 10 hours a week. So can the student achieve them in that much time over there? Okay? And of course, are they too much or too little theory oriented? Too much theory, they will understand this, they will understand this, they will understand this, theoretically analyze this, and there's no skill building. In today's world, that's possibly a red flag for most courses. In our case, we know even for, as I've shown, even for social sciences and various humanities courses, we put down, besides understanding and all that, we put down some skills that they must have. Generally, a richer course will have some objectives at the higher levels also. We just play at level 2 or 3, we'll understand this, we'll apply this. We'll understand this, we'll apply this. That's okay, but it's kind of low. You should have understand, apply, but then should be able to evaluate, should be able to analyze, etc. That should also be generally at a college level. We should have that. If there's too many at lower levels, understand, a few apply, maybe you're pitching it too low. If there's nothing at the lower level, all are will analyze, will evaluate, will create. It's probably too ambitious. You can't do it. You have to build some understanding before the student can analyze and do something. So you can do some qualitative analysis, some subjective analysis. There are some methods available to do a detailed analysis. You build a table and all that. I'm not a proponent of those. I would just look at them, look at the levels, and just make sure that there is a balance. You don't even need to do too much more elaborate than that. Okay, so let's just summarize, and then we'll have some discussion, and I'll leave you with the exercise. So to design a learning focused course, you have to state learning objectives in a course. If it's learning focused, you must first state what will the student learn. And that has to be stated in terms of, at the end of the course, because of this instruction, because of this course, the student would have learned this. And we've already seen learning is about what knowledge the student has acquired as a result of your instruction, of your teaching, and which is not just lectures, assignments, exams, everything that you do in your course. At the end of the course, what student has learned, what is his knowledge. Okay, so there must be in terms of students' knowledge and capabilities after the course. And a course should have typically 5, 6 learning objectives. It's not topics. It's not that student will understand concept A, will understand concept B, and you just list that. It is at a higher level. And Bloom's taxonomy framework can help in stating the learning outcomes, can help you think for stating the learning outcomes. And we can use the framework to analyze if the course is too low level, too ambitious, does it have a balance, and so on. Right? So once you have stated the learning outcomes, you've just stated the learning outcomes, then the next challenge is to design or plan the course such that the learning objectives will be delivered. That's your teaching plan. What will you teach? Lecture, assessment, everything, assignment, whatever you'll do in the class, outside the class. So what next challenge is this? And then execute the course assessment plan, of course, whatever you plan, you have to execute. And assessment. We've already discussed that. Learning outcomes, the two things that are left is what is your planning for teaching, and of course, actually teaching it. And assessment, what's your plan for assessment. So we'll discuss this in coming session. If you can get this course establishing of course outcomes, if you can internalize it, if you can get very solid with it, it sort of goes into yourself deeply, you will be that much better off lifelong. After I learned about learning outcomes, as you said, every course that was there in the institute, I would review the learning outcomes. Okay, you can do that. May not be able to do the entire course review, but you can certainly see the learning outcomes. So read up on that learning outcome. See examples from good universities. And maybe see some examples from poor universities also, where they will be stating the student will be taught this is the list of topics, etc., etc. I will post a paper or a link to the Bloom's paper on the Google. It's available. You can search for it. Okay, you can search for it. I will try to post that link there. So read that paper on Bloom's. It's a good thing to get an idea. Bloom's, the more you understand, it's a good thing to even have discussion when you have discussed in your faculty and so on. You can say this framework has proven over more than 50 years that it is still so widely used. Right? So it's a good idea to learn about it. And then take course descriptions of the course you are teaching. Maybe sit with some colleagues and then mention the goals. Just play around with the learning outcomes. Just play around different learning outcomes and see what comes out. Okay? And write the desired learning outcomes that you would like to see different this thing, see whether they're too ambitious. Just play around and state them in different ways and see how it works out. Okay? And then you can also, if you have a course, then once you establish some learning outcome, then you can see whatever is your plan or whatever is published as a plan on your site, see whether it is consistent with the learning outcome. So that's a teaching plan. See whether it's going to deliver the learning.